ninth webinar in series of an engineer's talk, a weekly online lecture being organized by the IEI Salem Local Center in commemoration of its 30th anniversary celebrations. I would like to invite now the chairman, IEI Salem Local Center, to welcome the guests on the gathering. Please, sir.
Yes, sir. Thank you, sir. Good evening to everyone. On behalf of the Institution of Engineers India Salem Local Center, I extend my warm greetings and a hearty welcome to you all for the 99th special webinar of our weekly online lecture series, Engineers Talk, being organized as part of the 30th anniversary celebration of our local center. I thank to you all. Even we have again celebration here, Puja celebration, Ayudha Puja and Saraswati Puja celebration. Also, you are joining and supporting us. We are cordially honored to have with us also today Dr. Anubhava Srivatsava, Assistant Professor, Department of CSE, Sharda University, Greater Noida, as our chief guest and keynote speaker. Sir, we sincerely thank you for accepting our invitation and for sharing your expertise today on the topic use of Google Earth Engine in processing satellite data. I also take this opportunity to thank our Honorary Secretary, Ma'am, Dr. Sri Davamani, for her dedication and for all the happening in our IESM local center. Also, we have dedicated engineers talk team members. A special thanks to Engineer Armugam sir and Engineer T. Thiagu for their continuous efforts and excellent coordination in making this series a grand success. My heartfelt thanks also to all the participants whose enthusiastic presence has been the strength of this initiative. With these words, I once again welcome our distinguished speaker, respected members, participants, and well-wishers. Let us do an enriching and insightful session. And thank you all. Jai Hind.
Thank you, sir. Now, I would like to introduce the chief guest and keynote speaker of today. It's my pleasure to have Dr. Anubhava Srivatsava, Assistant Professor, Department of Computer Science and Engineering, Sharda University, Greater Noida, India, today with us. With over 8 years of experience in computer science engineering, he has contributed his abundant knowledge and expertise to the academic and research community. He did his bachelor and master of technology at Uttar Pradesh University and Doctor of Philosophy from the prestigious Rajiv Gandhi Institute of Petroleum Technology. He is dedicated and keep learning to make professional advancement. His primary areas of expertise include remote sensing, artificial intelligence, and machine learning. He has passion on learning cutting-edge technologies that are influencing our digital world. He has made significant contribution to the field of computer science with several research articles and patents bearing his name. He has published 20 research papers in Scopus with H-index 10 at Scopus Provide. With these introductory words, I would like to invite Dr. Anubhava Srivatsava to present on the topic use of Google Earth Engine in processing satellite data. Over to Dr. Anubhava Srivatsava. Please, sir.
Thank you, sir. And welcome all the dignitaries. I am Dr. Anubhava Srivatsava and I am present here for sharing my thoughts over the Google Earth Engine and how the Google Earth Engine satellite data will be useful for processing in land cover, change detection, and other real-time change environment finding. So if you all allow me, I would like to share my slide with all of you, and after that I will start my presentation. Should I share my slide, sir?
Yes, sir, please.
Okay, that's right. Thank you, sir. Good day. And sir, as my topic is how the Google Earth Engine is good for optimizing satellite data, and how the Google Earth Engine we can use Google Earth Engine dataset for monitoring real-time change detection and other environmental detection. Okay, So first we should know what is Google Earth Engine and what is need of satellite data and what is need of real-time detection. First is satellite. What is just satellite data? Satellite data is nothing like we can say a data which we capture from the satellite by using some satellite mechanism from the NASA, from the ISRO, from Bhuvan satellite, from NASA, USGS, from European Earth Corporation, Sentinel in form of Sentinel data set, any other form, or we can say some types of data capturing from the remote sensing mechanism like from the lidar or from the other useful techniques. These data can be captured in very real time with high precision and high accuracy, and if these data are publicly available to in any form, but Google Earth Engine provide us capability of using these data and do the code optimization, do the machine learning algorithm in real time. So this tool is very helpful for all the persons who want the real time, who want the completion of real time chain detection and other types of chain detection. Like in present scenario, we are seeing that some glacier are melted, some flood areas are augmented. Then what are uses of these and what are outcomes of these, what are changes due to these floods, what are changes due to the fire accident, we can capture that by using real-time satellite data sets. It's in the repository of Google Earth Engine, there is petabytes of data, and Google Earth Engine itself having for long 40 times years back data. Means satellite in land named Landsat, which having imagery from 1972. We can use data from the 1972 year 1972 until now, and we can process the change, how the change is being accumulated, what are the impact of this change over this studies area. So over I'm going to in more depth Google over the Google Earth Engine. We can download we can upload our own vector file, and by that vector file we can manipulate, we can calculate the change. And if we calculated any data from our own tool, like from the Faro scanner, like from the other drone capture data, we can optimize that also in Google Earth Engine. So it's a very good tool for optimizing real-time data sets, and it's also provide publicly that we can use this in efficient way. So I want to show you how the Google Earth Engine code editor will look like. And in the catalog of data engine, like I say to you, 40 years of currently data and imagery are present in process of georeference data. Means data having information of their coordinates, like latitude and longitude coordinates, data presented in shape file, data presented in CSV file also. And the data is also having some digital elevation model, surface temperature. We can also calculate DEM, surface temperature, land cover chain detection, and other tools also. And climate weather, these are also we can calculate and compute it. This is the code editor of Google Earth Engine. At the last, I will show how Google Earth Engine will process data and how the Google Earth Engine will accumulate data and what are the functionality Google Earth Engine. But before that, I want to show all of you, and I want to integrate all of you from the code editor and how the code editor will work. So if you see there is the process of scripting, running the scripting, searching from data catalog. There is a script manager, there is a asset manager, there is a geometry tools available, like we can point out data in form of point, in form of pixel, in form of raw data, in form of vector data. And output of field is also present here, like in console output we can see how the data is being manipulated. In task manager we can see data is saved in our repository in drive, in our drive, or in our system in which form, like we can save data in .tiff extension, in .save file extension, and in another forms. This is the overall. We can save the data, we can point out the data, we can go to the any repository, any particular location over this by using this code editor interface. Means this is a code interface where we can have functionality of coding also in JavaScript. Google Earth Engine provides functionality of coding in Python language also, but code editor provides functionality of only in JavaScript. And for the using functionality in Python, we should go to move to Google Colab. So that's the other thing. In Google Code Editor, we can see all the functionality. We can select any data, any point in the over the map, just like the point out, go to the triggering to the that map console, and just select our desired location and point out, and what the computation we want, we can do over that. Mainly there are number of data set available in GE, but I want to introduce here only two types of data set, that is Landsat and that is second one is Sentinel. Landsat that I already discussed with all of you, provided by NASA, and from the 1972 till now, ninth version of Landsat is being introduced, from Landsat 1 to Landsat 9. I will discuss it later also. And the second one is Sentinel, that is launched by European Space Agency, that is Copernicus program, and it is till now launched till the Sentinel 1 to Sentinel 5. And from the 2013 to 2017 till now it is processing. And the latest Landsat data is formulated in 2022, and these data are updated in every 16 days. I will discuss all these things in later. Landsat satellite have carried 5 different type of center, means satellite having different type of sensor, and by using that sensor mechanism, data is captured by multi-spectral scanners in form thematic mapper form, enhanced thematic mapper form, enhanced thematic mapper plus form. Means data is from temporal resolution to extreme temporal resolution we can calculate. And last one is operational land manager, means where we can detect the lowest point and leakest point of the data set. Sentinel, like I said with all of you, Sentinel 1 is launched in 2014 and updated in 2016. Sentinel 2 launched in 15, and Sentinel 3 and Sentinel 4 and 5 are working. Mainly we are for land use monitoring, and from other functionality we are using Sentinel 2, and for the air quality mechanisms, like for the following of chain detection by using carbon shrinkage and other features, we are using Sentinel 4 and 5. And there are one more, like I have selected here. If we compare both having some functionality, like it's have resolution of 10 meter, and some data sets, some bands also. I will discuss it later on in the slides. That's every data having some bands, and combination of these bands are show us what our real eyes is seen. So data is in form of 10 meter, 20 meter, and 30 meter resolution. And Landsat data having two types of resolution, that is 30 meter and 100 meter. But maximum data is present in 30 meter resolution. Only TIRS band and panchromatic band data are present in 100 meter resolution. Like in both Sentinel and Landsat, data are presented in band form from band 1 to band 8, band 9, band 9, and combination of this band provides us data which we seen from our real naked eye. Like we are seeing data in RGB form, that is combination of three bands, blue band, green band, and red band. That the real data we are seeing. Though, so if we see Sentinel bands are from band 1 to band 12, and each bands having some wavelength, and by using that wavelength, our naked eye can see that data. And when we do the computational functionality, then by using these wavelength we do the optimization also. Same Landsat having some other band 1 to band 9, and in form of spatial resolution 13, 15, and 100, as we discussed earlier. So this is the generation wise Landsat description, that the first Landsat data is presented in 1972, and latest model, that is Landsat 9, is come in the scene in last November 2021, or we can say 23. And Landsat having functionality of existence of data till the 2030. Means if we see Landsat 1 is having data set of 1965 to 1972, Landsat 2 having data functionality of 1972 to 1979, so on. We can see that we can discuss, and we can, if we want to use data from the 1975, we having Landsat 2 having having data of year 1975. If we want data from the 1995, we having Landsat 5, Landsat 6. So if we want to do optimization and we want to do some computation over any area, then we can use Land 5 and Land 6. This is the combination the combination of bands we use to see, like for the image form, like if the image in the combination of band 321, combination of band 432, combination of band 742, combination of band 453. This is the natural color. This is the color infrared color. Natural color is what we are seeing by our naked eyes. Color infrared and false color is what programming tool is want to see in our data set. And the other two, short wave infrared and vegetative analysis data set, which are used for forming the growth of vegetations, growth of forest areas, growth of other stimulated areas like short wave infrared. From this data set, we are capturing NDVI, normalized difference vegetation indices, EVI, and others. Whatever plant growth, whatever forest growth, if we want to calculate, then we can go to this area. This is the how we process our data over the Google Earth engine. So this is a simple mechanism. We having some data from the Sentinel-2 and Landsat. We are just removing the atmosphere, removing the cloud and do the atmospheric correction. After geometric resampling, you can use our data for the computation purpose. If I go to in depth, that I have divided, users are divided land cover in basically 5 to 6 points. Like land cover is in form of urban land, grassland band, wetland band, cultivated land, water bodies, some surface or some park, open area, park area. So if you want to do do the computation of change detection, then we can do our compute area of from 1 year to another year and do the change detection algorithm, perform the change detection by using which area, which atmospheric area, which land use land cover types is increasing or which land use land cover types are decreasing. Through which I can calculate, user can calculate rate of change, land cover transfer matrix, spatial temperature distribution also. So this is the mechanism that Google Earth Engine easily provides us from the real-time satellite data. This is the process. If we want to see change in any plant, any cultivated land, any forest area, then we do the optimization of normalized different vegetation index, water index, green normalized different vegetation indices. And if you want to do change detection over the fire incident area, then we can also compute the burn rate also. What are the band? If we see normalized NDVI is banded ratioing of band 8 and band 5, NBR is ratioing of band 5 and band 7. I already discussed all of you the bands, what are the bands every image have. So if you want to do any classification, if you want to perform any classification by using real-time satellite data, we just go to the Google Earth Engine. We write some basic code that every Python user, every Google user, or every computational person know, and from that we just do the computation and we find what are the change detection over that area, what are the rain temperature area, what are the forest fire visibility we can process. I will show in the later part. This is the mechanism showing that how the Google Earth Engine is useful for computing change and what are the attributes and which sampling algorithm processing we can use by using the chain detection. So if you focus, we perform the LULC classification. We can use any supervised classification or unsupervised classification. Supervised classification like CART, random forest, gradient tree-boost, or any deep learning approach, or we can also apply any unsupervised classification like k-means and so on. And we from the change in from 1 year to another year, we can find the change detection over the studies area. This is the broad view of Google Earth Engine or any satellite data. If we are having some satellite data, then this is a broad view. We can predict environmental risk also. We can detect the change in land cover area. We can predict the process of being loss of due to the flood, due to the fire, and other susceptibility also. That's all from my slide. I want to show you some functionality of how the Google Earth Engine processing is useful useful for the and how the competition is doing over this. So if you focus over my imagery, this is the my Google Earth Engine code editor. And if I go to the, if I select any, I can select any code, any data set, any study area. This is the code, this is the code of my, I have calculated some burn rate. Like if you focus, I have clicked here, and my land chart inspector is saying this functionality. Also Google Earth Engine having that, like we can detect modis EVI, we can detect landscape EVI, we can detect forest fire incident. And if I want to go to any study area, I just write the study area. Like here I am writing Dehradun. Suppose I want to go to the Dehradun and do the computation of Dehradun study area. So I just go to the, I just write here Dehradun, and my core processing will shift it to Dehradun. Like this is the Dehradun. And if I want to do any computation over this study area, I just select, this is being sampling because I just selected my data set. If I want to do select, I just use the pointer marker, and I can select the data set. So this is the, these are the premises, and these are the code for rainfall prediction, like any study area having which type of, I want to minimize this. Yeah, this is the how the, if I calculated daily rain level in year 2022, because here I selected year, I can easily select that year, and then I will find the result in this, in the form of this graph, in the form of this everyday rain prediction, everyday rain perception. If I want to calculate temperature of any study area like this, I can calculate the study area temperature in Kelvin here. Like if you see, everyday temperature is showing here, like 293, 294, 295, so on, how the temperature is being increased, how the temperature is being decreased. For the detail analysis, I need more time. I need more time. Today having only half hour, so I am showing quickly everything. But if I found any good time from 1 to 2 hour, I will show everything in detail. If I want to calculate NDVI change or any study area, mean value of NDVI, standard deviation value, I can just write our code into the code editor and just calculate mean value of that NDVI, or standard deviation value of that EI. Like band 5 having some mean value, band 5 6 and also like some concentration of gases. Also here I calculated NO2 and air pollution index. Also I have done some research work over the CO2 monitoring, also some other study area. If I want to do, if any user want to do any land use land coverage change detection, then just sampleize your data. He or she able to go to the site, just collect some physical points. Using that physical points, he can match that physical points with satellite imagery and just calculate the change in studies areas, and he or she can calculate the existence urban area, existence fire area, existence water area, so on. These are the competition which I have done in my classification. If you see, there is lots of competition, and lots you all people also can do by using just a sample amounts of code, nothing else. So that's all from my side. I would like to thanks the um, thanks to everyone for giving me some sort of satisfying of time to discuss my knowledge and expertise. Thank you, sir. I'm audible.
Oh, yes, sir.
Yes, sir. Audible, sir.
Sir.
Yeah.
Shall I conclude, sir? Or else some, is anybody having any doubt in this?
Yeah,
Any
please.
clarifications?
I would like to.
Case?
Sir, I have one doubt, sir. Whether we can use the live data, sir, for processing?
Yeah, we can use live data. Means I have also said that data imagery is updated in every 16 days. Like if I want to use data of 8 December data, like until now I have 10 December of data. So if I want to use the 10 December data, I can use that for predicting flood in like northeastern area, or predicting some fire incident area. We can detect also. Google Earth Engine having capability of that also, sir. Or even
Okay,
we can
okay.
also integrate our own data. I discuss it also in, if we having data in vector form like shape file, or data in raw form like CSV file, then we can integrate our data also. And by integrating that we can also do the analysis. Like I want to show one thing more here from my, like if any user want to share add some asset, then by using this asset mechanism, like I have, if you focus in the assets, using this assets mechanism, user can upload their own repository. Like I have uploaded my this imagery data. If user having any CSV file, any save file, then he or she can upload their own imagery.
Yes, sir. Thank you, sir. Thank you.
Thank you.
Okay. Is there any further queries, sir? Okay, in that case, let
I would
me
like to
conclude.
answer, if please, if any query anyone have.
Yeah.
I have summarized my all research in very short form.
Hmm.
I think you all get what I want to share with all of you.
Yes, sir. Wonderful session, sir. Thank you.
Okay.
Thank you.
Okay, Inza, thank you. Thank you, sir, for your presentation on the topic use of Google Earth Engine in processing satellite data. And I would like to invite the Honorary Secretary of IEI Salem Local Center to propose vote of thanks. Please, ma'am.
Thank you, sir. Most respected our chief guest and keynote speaker, Dr. Anubhava Srivatsava, sir. Respected Chairman, Dr. K. Tangaraj, sir. Respected committee members from state and local center, council members, fellow engineers, respected Arumagam, sir, and Thiagu, students from various organizations. Good evening to all. It's my distinct honor and privilege to deliver vote of thanks for today's enlightening seminar on use of Google Earth Engine in processing satellite data. This is 99th special webinar. I would like to extend my deepest gratitude to our esteemed speaker, our chief guest, Dr. Anubhav Srivatsava, sir, Assistant Professor, Computer Science Engineering, Sharda University, Knowledge Park 3, Greater Noida, Uttar Pradesh, for taking the time to share your valuable insights on handling and analyzing the satellite data using modern tool. It widened our understanding and inspired us to explore further applications in research and industry. Thank you so much, sir. It is very interesting topic. Actually, for our students, it is very much interested. We extend our gratitude to our chairman, Dr. K. Tangaraj, sir, who is vision and guidance for driving force behind all the events what we conducted in the IEE seminar. Thank you for introducing our guest and also make this wonderful session. Thank you so much, sir. I extend my sincere thanks to our Engineers Talk Team series for their continuous guidance and support always. It's my privilege to thank our engineer N. Arumugam sir for his unwavering support in making this seminar a success. I would like to place a appreciation to Mr. Thiagu for his sincere effort always doing for IEA Salem Local Center. With this, we concluded today's program. Thank you all once again, and we look forward to more such knowledge sharing session in the future. Thanks.